All right, so I got cut off on the last video telling you about the x-intercepts of this problem. I was kind of hurry-scurrying through this problem to show you what the x-intercepts would look like. And so once we find the values that make this equal to 0, the next thing we do is we put them in ordered pairs because the x-intercepts, right, are an x, comma, y, and an x, comma, a y. And so those are the x-intercepts. Now when we have a quadratic, right, an ax squared plus a bx plus a c, then we're going to get 1 or 2 or 3. And let me just show you kind of why that is. So if I have a parabola looks like this, or a parabola looks like this. And one of the things that we could have is we could have the coordinate system going through the parabola like this, right? Or the coordinate system going through the parabola like this. And in that case, we would have 1, 2, or 1, 2 ordered pairs that are our x-intercepts, and that's what we see here. Now, that's not the only game in town. Another way of looking at this, let me do a different color so you see them differently. Here's one, and here's another one. And this time around, another thing that could happen is that my parabola could set right here on the x-axis, or here it could set right on the x-axis over here. And in this case, we would have one x-intercept. And you know, there's actually even a third option. Let me draw this one in green. So here's a upward facing one and a downward facing one here. And the other option is that this thing could be totally above the x-axis altogether. Or this one could be totally below the x-axis here, in which case there would be no intercepts whatsoever here. So no x-intercepts in the green one. And then we could also have the option of having one x-intercept in the yellow one. And then the other third option is what we saw in our example, our first example here, is we could have two x-intercepts. Now this is when we have a quadratic equation, an ax squared plus a bx plus a c. If we put that up to a cubic, we could have a potential of 3, and down to 0. And that was linking back to what I was saying in the last video where I was talking about the number of solutions that we could possibly have. Now let's take a look at our next example here. Let's find the x-intercepts of this parabola. Well, in order to find the x-intercepts of this parabola, the first thing that we want to do is factor it. So this is a perfect square trinomial, right? X plus 1 quantity squared. Now we're going to let y equal to 0, and that's going to give an x-intercept. So y equals 0 is equal to x plus 1 quantity squared. And so now we'll set the x plus 1 equal to 0. We don't have to solve for both or two of them, right, because they're exactly the same. So we'll set it equal to 0, and so we find when x is equal to -1. Now this is one of those cases where there's only one x-intercept because this parabola actually sets on the x-axis. So this was an upward facing parabola, and it would be setting on the axis like this, right here, like that. And it would be, oops, not quite there. It would be setting over a little bit more. This blue line would go a little bit over there. And this value of our parabola here, this would be here at -1 and 0. And that's what this is telling us about. So that's the x-intercept of a parabola. Let's see if there's another example down here. Yep, one more here. And so why don't you try this one on your own? Oops. Why don't you try this one on your own and see if you can find the x-intercepts and then come back and check it. Okay, so here you can see the solution to C, so you can check yourself, and I've written a little bit about it so you can check yourself through. Remember, this is a binomial, difference, squares, difference of two perfect squares. The root of the first one and the root of the second one is how we factor it, sum and difference, right, the conjugates. And then once we've got it factored, then we're going to let the y equal 0 to solve the y, or for the x-intercept, just like a linear equation, by the way. And we set that equal, then we apply our zero factor property, solve each of these, and we write them as ordered pairs. Remember, these are the intercepts, therefore they need to be ordered pairs. I'm kind of picky about that. All right, so that's solving or finding the